Background and history. 1. On January 28, 1986, the Space Shuttle Challenger disintegrated 73 seconds into its flight, resulting in the deaths of all 7 crew members. 2. The mission, designated STS-51L, was a high-profile flight carrying the first civilian, schoolteacher Krista McAuliffe, into space. 3. The disaster was attributed to the failure of an O-ring seal in one of the shuttle's solid rocket boosters, leading to the breach of the external fuel tank. 4. The Challenger disaster brought a temporary halt to NASA's Space Shuttle program and prompted a thorough investigation into the technical and organizational causes. Historical impact. 1. The Challenger disaster had a profound impact on public perception of space exploration, causing a re-evaluation of the risks and complexities involved. 2. It marked the first in-flight fatalities in the history of American human spaceflight and became a somber milestone in the space program. 3. The tragedy led to a suspension of the Space Shuttle program, with a pause in shuttle launches until corrective measures were implemented. 4. The incident highlighted the challenges of balancing the ambitious goals of space exploration with the need for safety and rigorous engineering practices. 5. The aftermath of the Challenger disaster prompted changes in NASA's organizational culture, safety protocols, and decision-making processes. Historical milestones. 1. The launch of Challenger on STS-51L was intended to be a landmark mission with the inclusion of the first private citizen, Krista McAuliffe, as part of NASA's Teacher in Space project. 2. The crew also included astronauts Francis R. Scobie, Michael J. Smith, Ronald McNair, Ellison S. Onizuka, Judith A. Resnick, and Gregory Jarvis. 3. The disaster occurred shortly after liftoff, with the shuttle breaking apart and debris falling into the Atlantic Ocean. 4. The Rogers Commission, established to investigate the incident, unveiled findings that addressed technical flaws and communication failures within NASA. 5. The Challenger disaster led to a redesign of the shuttle's boosters, enhanced safety protocols, and a renewed emphasis on ethical decision-making. Technological advancements. 1. The investigation into the Challenger disaster resulted in redesigns of critical components, including improvements to the O-rings and booster joints. 2. Technological advancements focused on enhancing the safety and reliability of the Space Shuttle fleet, incorporating lessons learned from the tragedy. 3. The implementation of stricter pre-launch criteria and improved communication protocols aimed to prevent similar failures in future shuttle missions. 4. Changes in the shuttle's engineering and design, informed by the investigation, contributed to the overall safety of subsequent shuttle launches. 5. The technological advancements resulting from the Challenger disaster became integral to shaping the future of human spaceflight. Challenges and risks. 1. The Challenger disaster exposed the inherent risks of space exploration, emphasizing the complexities involved in launching and operating spacecraft. 2. Organizational challenges within NASA, including communication breakdowns and decision-making processes, were identified as contributing factors. 3. Balancing the pursuit of ambitious space missions with the need for thorough safety assessments posed ongoing challenges for the space agency. 4. The tragedy highlighted the importance of maintaining a culture of transparency, accountability, and constant vigilance in the face of potential risks. 5. Overcoming the technical challenges associated with the redesign of shuttle components required a collaborative effort from engineers, scientists, and decision-makers. Future prospects. 1. The Challenger disaster prompted a re-evaluation of NASA's approach to space exploration, emphasizing safety and prompting a reassessment of future missions. 2. The tragedy contributed to the development of a more robust safety culture within NASA, with lessons learned applied to subsequent shuttle launches. 3. The Space Shuttle program continued after the implementation of safety improvements, with missions resuming in 1988. 4. The incident served as a catalyst for advancements in space vehicle design and engineering, contributing to the development of safer spacecraft. 5. The lessons from the Challenger disaster continue to inform the planning and execution of human spaceflight missions, including those conducted by private space companies. Controversies and debates. 1. The Challenger disaster sparked debates about the prioritization of safety versus the pressure to meet ambitious launch schedules. 2. Controversies arose regarding the decision-making process leading up to the launch, with concerns about communication breakdowns between NASA and the contractor, Morton Thiokol. 3. Ethical considerations surrounding the inclusion of a civilian, Krista McAuliffe, on a space mission raised questions about the balance between public engagement and crew safety. 4. The Rogers Commission's investigation revealed internal dissent and concerns among engineers regarding the launch decision, sparking debates about the influence of organizational culture on safety. 5. The aftermath of the Challenger disaster fueled discussions about the broader societal implications of space exploration and the responsibility of space agencies in ensuring public safety. Additional information. 1. The Challenger disaster was witnessed by millions of viewers as the launch was televised live, making it one of the most publicized space-related events. 2. The explosion of Challenger led to a temporary suspension of the Space Shuttle program, causing delays in subsequent missions. 3. The incident had a lasting impact on the families of the crew members, the NASA community, and the broader public, shaping perceptions of space travel. 4. The Challenger Accidents Memorial at Arlington National Cemetery pays tribute to the crew and serves as a somber reminder of the sacrifices in the pursuit of space exploration. 5. The Challenger disaster led to changes in the curriculum and goals of the Teacher in Space project, aimed at promoting space education and engagement. Fun facts. 1. Krista McAuliffe was selected from over 11,000 applicants to be the first private citizen in space as part of the Teacher in Space project. 2. The tragedy prompted the development of the Space Shuttle Solid Rocket Booster, SRB, redesigned joint, enhancing the safety of future shuttle launches. 3. The Challenger disaster resulted in the establishment of the Challenger Center for Space Science Education, dedicated to promoting STEM education. 4. The decision to proceed with the launch despite concerns about O-ring performance became a case study in engineering ethics. 5. The Challenger crew included diverse professionals, reflecting NASA's commitment to inclusivity in the space program. Dark side. 1. The dark side of the Challenger disaster lies in the profound loss of 7 lives and the emotional impact on their families, friends, and colleagues. 2. The tragedy cast a shadow over the optimistic vision of space exploration, reminding the world of the inherent risks and complexities involved. 3. The organizational and communication failures within NASA and Morton Thiokol revealed systemic issues that required remediation to prevent future disasters. 4. The incident raised ethical questions about the inclusion of civilians on space missions and the responsibility of space agencies to prioritize safety over public relations. 5. The legacy of the Challenger disaster serves as a cautionary tale, underscoring the need for continuous vigilance, transparency, and adherence to rigorous safety standards in the pursuit of space exploration.